back. Um, or we're just starting. I don't know if I recorded the first part or not, or streamed it. I'm going to assume I streamed it. Did the right thing. If not, hello and welcome to 30 Days Lost in Space. We'll get there. We'll get there eventually. Oh, I don't think yeah, I just got a notice that I was streaming. So, yeah. Maybe, maybe I was only recording it before. Let me check my movie folder real quick. Movies. Mm-hmm. Mm-hmm. Uh-huh. Uh-huh. I think this might be a fresh start for us. Yep, cool. I just recorded the first part. Tell you what, I'm going to upload it on my YouTube channel. So let me do the basic spiel again, just so you all know where we're at. We are doing 30 days. Oh, you can't see that either. Oh, I've got a whole thing going on here, y'all. Great, good time. We're doing 30 Days Lost in Space. It is a little adventure kit that teaches you circuits and coding, all ages 12 plus. That counts me in. Great. I'm gonna go back. So the exciting stuff you missed last time was me checking my messages. The stuff you. I've been talking for half an hour already. Here we go. Here's all the bits and pieces I got. Let me hide this thing. Bloop. I got a lot of bits and pieces. I got a little Arduino board, and you can see it's lit up. It's plugged in. The drivers should be working now that I've restarted. And I've got a new camera set up here. I'm using an old webcam that is not great, but I got a new sweet little setup over here. Here's the stuff. So I don't know how this is going to work or if it's going to work at all, but I would like to get started on this little project. So far, I've been reading instructions for installation and watching YouTube videos, which you can see here is going great. Let me get my window capture back here. Yep, that's the one. And there we go. Incoming broadcast. Hey, look at how great that looks. Cool. Yeah, I'm just gonna put that right here for now. Cool. I'm gonna read a little of this just to get to see if we've got stuff here. Their site has not been super great, so it's just a little pokey. All right. I was on the installer guide here. I'm watching things. Yeah,
open
great.
the Arduino executable.
I did that.
Let it open. Give it the permissions it requires.
I did that.
I'm going to very quickly minimize this. And you should see a screen that looks very similar to this. Now, what we're going to do
Close.
is we're going to plug in the Hero board over the USB line
Done.
directly into the USB port. As you can see, it has lit up, meaning that the power being delivered to it, and that everything should be hooked up properly. I'm going to go to Tools. This is going to be the first step, Tools. Go to Board, make sure Arduino Uno is selected, and then go to the port. And I'm going to make sure that I go and select the serial line that it is talking over. You might see a Bluetooth line, or you might see some other ones. You're going to want to make sure you're talking over USB to the serial connection. And it should update down here when it's connected. Arduino Uno on dev USB serial 1420. It looks like it's connected properly.
I was just futzing with Windows. I missed all of that. Oh, ADHD and allergies. Cool. I've done this before, but I don't remember exactly how it works.
You might go to Board, make sure, and that everything should be here. Permissions it requires.
Okay.
I'm going to very quickly minimize this.
Mm-hmm.
And you should see a screen that looks very similar to this.
Mm-hmm.
Now, what we're going to do is we're going to plug in the Hero board over the USB line directly into the USB port.
Mm-hmm.
As you can see, it has lit up, meaning that the power being delivered to it,
Mm-hmm.
and that everything should be hooked up properly.
Mm-hmm.
I'm going to go to Tools. This is going to be the first step, Tools. Go to Board, make sure Arduino Uno is selected, and then go to the port. And I'm going to make sure that I go and select the serial line.
Oh wait, okay. It's not that yet. It's not that yet. Board tools, no. Board. Boards manager. Arduino boards. Arduino Uno. Is that what they said? This is a Hero, not an Uno. Is that the same thing? Maybe. Let's find out.
Line, you might see some other ones. You're going to want to make sure it's selected, and then go to the port. And I'm going to make sure that I go and select the serial line that it is talking over.
Okay, serial line. Got it. Tools, port, USB serial 110. That sounds promising. Cool.
You might see a Bluetooth line, you might see some other ones. You're going to want to make sure you're talking over USB to the serial connection, and it should update. Down here, when it's connected, Arduino Uno on dev USB serial 1420. It looks like it's connected properly, but to verify that it is, we're going to upload our first little bit of code to here. So let's go to File, Examples, Basics, and we're going to click the Blink program. This is a sample code that we're going to quickly compile and run on our hero board. We can click Verify, the compile sketch, and then we'll hit Upload.
Okay, let's back up.
Verify, and we're going to click the Blink.
Blank. I don't think I have a blank. File, Examples, Basics, Blink I have. Maybe that, did you say blink instead of blank? I don't know. Cool. Great. It opened in a different window that you can't see. Let me bring you over to that one. So I'm learning here, clearly. I'm going to, yeah, let's get that other window hooked up. This one? Maybe. Nope. Is it? I see the one. Blink. Nope. Dude, why is that not doing it? Cool. So you don't get to see the IDE, but there's a program. I need to do what now?
Program. This is a sample code that we're going to put our first little bit of code here. So let's go to File, Examples, Basics, and we're going to click the Blink program. This is a sample code that we're going to quickly compile and run on our hero board. We can click Verify.
So this ID, okay, looks a little bit different. Verify, compiling sketch. Cool. Sketch uses 924 bytes. Ridiculous, outrageous. And so here's the board here, and I haven't even looked at the code yet, but I assume when I hit run, it's going to blink the lights. Yeah, look at that. Blinky blinks. Great. So it is hooked up to the board. Sounds like we are ready to roll.
The compile sketch, and then we'll hit Upload.
Upload.
Now, as I hit Upload, you'll notice that the lights on the board start to flash, meaning that it's successfully doing something. And as well down here, it says done uploading, so it has successfully uploaded. And the little LED that is currently on the board is blinking on every second, off every second, on, off.
Yeah.
To verify that this is still working correctly, we can change this down here from...
Wait, did it do 1 per second? Because it seemed like it blinked real fast. Let's run this again. Yeah, let's run it. That's blinking real fast. That's more than 1 a second. Oh, now it's doing 1 a second. Oh, maybe the blinkies part was when it was uploading. Top tip, use a sample program that does something besides what it does when it uploads. I wish I could show you all this. I have so many sites to show you. You know what, maybe, what if I put a new window capture in there? That's that one. Welcome to futzing with USB. Not USB, OSB. OBS. OSB is for building things with. And boom, there we go. Good buddy. Let's make you a little bit smaller, shall we? Okay, let's make you a little bit smaller, shall we? Great. Cool, so this is what this program looks like. This is the up in the upper left-hand corner, which only highlights, it doesn't show my cursor. Here's the compile button. This is the what he calls the upload button, and it says upload on the tooltip, but it looks like a run button. So it is running this thing. I've literally not touched an Arduino in a decade, but I imagine it hasn't changed that much. And the comments say here, so I'm assuming it's like a lot of other languages like processing or whatever that have this automatic thing set up. The setup runs once. Hey, it says that. The setup runs once when you press reset or power the board, and it's setting pin mode LED built in to output. Great, so setting that to an output. And then this loop is just going to run forever. Right to high, delay for 1,000 milliseconds, right to low. Great. Super easy. We can do that. Any more things that we need to know here?
1,000 milliseconds to 100 milliseconds, or the equivalent of a 10th of a second re-upload.
Yeah.
And you'll notice that blinking speed changes to a substantially faster speed than it was before. And going blink, 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 blink.
Yeah.
So the code is working, the board is talking to the Mac, and you should be all set up to go to continue programming.
Great. Back to this exciting guy here.
Greetings. I'm speaking to you.
Yep.
Program.
We already watched this part.
Electronic systems provided for installing the Arduino software. Welcome back. At this point, you should have successfully installed the software on your computer necessary to work with the Hero, with our controller. In the days ahead, Our plan is to work on building electronic systems alongside the computer code that will function with those electronic systems in order to produce the desired capabilities and results that we will need in order to get your shuttle flying. We'll start out simple with small steps, and then with each succeeding day, we will add new features and new knowledge until at the end, you're expert and you will have acquired the ability to fly this shuttle to a safe harbor. Today, we will start with just a very modest test. In fact, we won't actually be building any external circuitry outside the Hero, and we will wait to do that until tomorrow's session.
Cool.
But today, we'll just be testing our ability to command the Hero and have it blink some of its onboard lights, just as a warm-up for doing some of the more important and practical jobs that we have ahead of us. This is a first introduction, and unless you have previous experience, some of the instructions and some of the code that we'll be using will seem obscure at first. And don't worry, in tomorrow's sessions, we will be going back and more slowly reviewing the new concepts, the new language that's needed to follow everything. So don't be worried if some of these things go by fast in today's example. But to get started today, we will have our Hero run a pre-saved example program. This pre-saved example is called Blink.
We literally just did that. Okay.
Using your Arduino software.
Talk to your other boy.
On our Hero sketch window. We'll see
Did that. We did all this part. Open, boom, great. Did that.
Is output, which means we're going to tell it what to do.
Great.
Down below here, in on, there, set it to load.
Yep, we did all that part.
And so you can see that the port here is USB serial 1420, correct? And so I can go ahead now and try to be seeing
I
the onboard
don't have a
LED
PC,
blinking
sorry, man.
according to the instructions in the program. You should see the Hero functioning as intended. The onboard LED is now blinking on 1 second, off 1 second,
exactly
on 1
what we
second, off
have.
1 second. So this is gratifying, and it's telling us that our Hero is communicating and functioning properly, and we're ready to perhaps ask it to do more sophisticated things.
Yes, let's do
Now,
that.
you can see that we controlled the Hero by giving it instructions through the code that we wrote, and in this case, code that someone else wrote, and then upload it. And among the things that we'll be doing in the future is we'll be modifying code, testing it, finding bugs, finding mistakes, and modifying them. And we'll just give a little example here before we finish in order to give an idea of what you might do as you're working. I right now have this simple on and off blinking sequence of commands.
We're going to change the speed,
I
aren't we?
also wrote my own set of commands to replace those that I thought might be worth trying out to see if they would work.
Okay.
So what I'm going to do is I'm going to delete those lines.
Oh my.
So I can select them and delete them and replace them with a new set of lines. You'll notice that there are more now and they're slightly different. I'm still turning the light on and
Golly.
off. But in this case, what I'm doing is I'm doing it with a different set of timing. So I'm only leaving the light on for 150 milliseconds and then turning it off and doing that 3 times in rapid succession. And then, so there's high, high, high 3 times. And then following that with a long delay of 1000 milliseconds. So this is when I upload it, should change the pattern of flashing from on and off to 3 short flashes and then a long pause. And
Yeah,
then repeat.
I believe you.
So when I write new code, it's usually a good idea to test and make sure that there aren't any mistakes in it. So I will click the verify button to make sure that it compiles correctly. It gave me no error messages. It says that it was done compiling. So I'll go ahead and upload it as I did before. So as I upload the code now,
Blink, blink,
I
blink.
can see that once it's done, here I
Blink,
have 3
blink.
fast blinks and a long wait, 3 fast blinks and a long wait.
Yeah, cool.
You may want to try your own modifications of this kind just to make sure that you understand how this all works, although we'll be learning more about how to construct code that doesn't have errors in construction in it as we work through tomorrow's session and the days following. So to this point, this has basically gotten us where we wanted to go on the first day, which was got our Hero successfully operating and connected
Great.
to start off. Andrew, hearing from you.
Great. Cool. We did all that part. I don't need to write a bunch of like. I know that works. Yeah, I'll do. Oh, look, I'll do 150 here, and it'll like get a different. Boop, boop, boop. So it only stays on for 150. Yeah, this is easy baby stuff. I don't know. Do we want to keep going? I don't know. I mean, I'm going to keep going. Do we want to keep going here? Let's see. Day 2. It's really dark in here. I'm just going to see what this is. No promises. This is fine. This is fine. So we've got a, let me close this out, actually. So it looks like we're going to be playing with the breadboard, which is so hard to see under this light. Maybe if I turn the light down. Nope, that's just on and off. There we go. Is that better? Worse? A little bit better? Okay, yeah. Cool. We have some lighting here. And we've got lighting everywhere, so. Here's our breadboard. If you all haven't played with breadboards before, these are little holes that are connected. You can't see them on the back here. These are connected with copper, usually strips, on the back there. And so you can use this to simulate a circuit and use wires to jump between them. Super nice. As you can see in the video here, we're probably going to hook up an LED to this and make it blink. I am all for that. How long is this video, and how many times will I have to stop it? Well, cool. Here's our code. All right. Let's see how long this is going to take. 27 minutes. 15 minutes now.
Greetings from Rescue Shuttle Control.
Greetings.
Our telemetry indicates that you succeeded in starting up your Hero controller.
We sure did.
We're ready to start working with it.
Yep.
That's great news. That's the first step in getting your shuttlecraft
Are you reading from a script down there, man? Okay.
functional and ready to get you home. One of the first things that you're going to need to do is learn how to turn on the lights in your shuttle
Cool.
and how to control the various functions on board.
All right.
Doing that is going to involve developing some knowledge both of analog circuits and of the digital computer control
Sure.
that's provided to you by your Hero.
Tight.
So we're going to walk through the basic use and the basic concepts of both of these functions during today's session. And by the end of today's session, we hope you'll have the lights on. You'll notice that in addition to the Hero device that you got in your shuttle, which connects to your ship's computer through the USB cable, you have a white rectangular plastic board, this thing called a breadboard. Its purpose is to allow you to quickly and easily assemble circuits from discrete components. And by discrete components, I mean things like what we have here: resistors, light-emitting diodes, wires. And we will discuss what those components are and how they're used very soon. But I first wanted to sort of show you the breadboard that we'll be using in addition to the Hero controller. Now, let's back up for a moment and talk a little bit about circuits, analog circuits. A circuit is a path or multiple paths through which electricity can flow around.
Yeah, okay.
Now, the idea that
Yep,
you're
it's like water. We get it. Yep.
More water will flow electric
Yep.
circuits.
Great.
The voltage, or another word for voltage is potential, that's provided, say, by a battery or a power supply, is similar to the water pressure.
Yep.
Now, we have less resistance
Yep.
to a pipe with a narrow diameter that restricts the flow of water, and a low
Yes,
value
that's
resistance
exactly how it
may be
works.
analogous to a wide pipe with a low resistance.
Did y'all know that electricity doesn't actually flow through the wires? It flows outside of them, around them, and in a big yeah, look it up. There's a sweet video that explains it. It's the video where it's like, oh, we have a switch next to a light bulb here, and wires go for a mile in either direction. How long will it take for the light bulb to light up? And the answer may surprise you. Doctors hate it. So, but yeah, this is good enough for our purposes.
Resistance to flow. Now, if we want less current to flow through a circuit, for example, we would naturally insert a resistor that had a high enough value of resistance to reduce the amount of current to an acceptable level. And we can figure out how much current will flow through a resistor by taking the voltage applied,
Pivnert.
like the pressure in water, and dividing that by the resistance. So, as an example, our Hero right here is able to supply for us a voltage of 5 volts. There's a slot right here, a pin on the Hero that's labeled 5V.
Is there? Where are we at, buddy? 5V. Look at that. Oh yeah, there's a 5V out there and a 3.3V. Great, cool. I can make. Getting a little bit ahead of myself, but when we get through this whole spaceship thing, I'm totally making some synthesizers. So
That corresponds to 5 volts. We also have here some resistors like this one, or the one that's currently connected to the breadboard right here, that has a resistance of 220 ohms. So if I want to send current through this resistor using my potential of 5 volts, the current that would flow would be 5 divided by 220. So if you calculate what that value is, 5 divided by 220 is 0.023 amperes. So that turns out, luckily for us, to be just about the right amount of current necessary to illuminate this device, which is a light-emitting diode.
Is the device.
It's like a light bulb, but unlike an incandescent light bulb,
It's nothing
it
like a
doesn't
light
function
bulb.
by heating up. It functions by converting electrical energy into light. So we wouldn't want to send too much current through our LED, because if we did that, we might be at risk of burning it up.
Let it
So
smoke out.
knowing the proper value of resistance to put into our circuits to limit the amount of current is pretty important. So this is already something valuable that we've learned about these circuits, and one of the basic ideas that we want to understand in order to design our own circuits. But now, before we go any further with that, we have a little bit more to learn. We want to not only be able to put together an analog circuit and have current flow through it of a desired amount, but we also want to be able to control our circuit by giving instructions to the Hero through our computer. Now, it turns out that by writing correctly constructed code, we can tell the Hero how and when to apply voltages to certain places on the Hero board, and use that to, say, illuminate a light-emitting diode. Now, let's go ahead. We're going to talk about how to construct that code and how to command the Hero in a moment. But first of all, let's talk a little bit more about connecting our circuit together and connecting it to the Hero.
Cool.
One way to connect circuits together is with wires, like the wires that we have right here. But if we have to solder everything together permanently, this can be very tedious and time-consuming. And it's also inconvenient if we want to change our circuit. So, for example, if we want to revise it, or we have a new idea, we want to try a new design. So the breadboard here is there to make this job much easier, because instead of having to permanently solder components together, we can just connect parts together end to end by pushing their ends into the holes on the breadboard. The pins of our components fit right into the holes of the breadboard. The reason why that's helpful is that the breadboard provides electrical connections between holes in the same row. So, for example, all of the holes here in row 6 are connected together electrically, or all the holes in row 5. Turns out we've also got connected holes in vertical lines as well. This red, and this blue vertical line are also connected. And although we won't use those today, we'll find that it'll be convenient for us in the future to be able to use both horizontally and the vertically connected rows of terminals. For now, though, what we're going to do is illustrate how we might use the breadboard and the 5 volts provided by the Hero to illuminate a light bulb or a light-emitting diode. As I mentioned before, this light-emitting diode can emit light when current flows through it.
Mm-hmm.
And unlike an incandescent light bulb, a light-emitting diode only works properly when current flows in one particular direction.
Yep.
That is, in through the long
because it's a
prong,
diode.
out through the short prong. A way of remembering that is that you need to connect the longer prong to the higher voltage. That would be to the 5 volt side. And then the shorter prong would go to the low voltage side, or 0 volts. So let's see if we can use the breadboard to connect this LED to a source of voltage and get it to illuminate.
Yes.
Now, as I mentioned before, there is a pin on the Hero labeled 5V for 5 volts. So we're going to take a wire and connect it to that 5 volt pin.
Okay.
Then connect that wire in turn to a particular row
But it's
here
so
on the
far
breadboard.
away.
In this particular case, I've chosen to connect it to row number 6. There's nothing important about that. Just pick that at random. Also connected to row 6 is one side.
Okay, so I've unplugged my boy here. We've got our 5 volt buddy here. So he's going right there. Boom, right there. And that is getting connected to the breadboard, wherever we want, really. So I'm just going to throw this, I'm just going to throw it here. It looks like there's some extra little, oh, there's numbers. Oh, they gave us numbers. Okay, cool. I'll throw it in number 6, like you said, so nobody there gets confused. Cool, so power to the board.
Side of this resistor, this 220 ohm resistor. If I were to then connect another wire from here back to 0 volts, or ground, ground is another shorthand name for 0 volts in this circuit, then I would have current flowing through the resistor in a circuit. That wouldn't be too useful because the current really wouldn't be doing anything. So rather than simply sending a wire back to ground here, I'm going to send the current through the LED and see if we can get the LED to light. So let's connect the long end of the LED to row 10, like so. And it
Did they talk about putting the resistor in? I'm putting the resistor in here. So I want the power to go, here's on the, here we are on row 6. So I'm going to take the resistor, and resistors go both ways, if you know what I mean. Speeds current flows through them both ways. This is going to make great TV, I bet. So there we go. So resistor goes in both holes, like you do. God, I have such sausage fingers. Oh my gosh. Cool. Makes for great TV. So diodes connected. It's not a diode. It's not a diode. It's a resistor. Power's coming in here, going through the resistor, and now I want the long leg of the LED to go into where the power is coming from, and that is from the LED. One thing that you need to be careful of is that these wires don't touch each other on the outside there, because that could be a bad time. So I'm just going to throw our LED in here, bloop, great. So power is coming from the board, going through the resistor to slow it down a little bit, and hitting the long leg of our LED, which will make it light up. When the circuit is complete, let the man finish talking while I get a...
It just so happens that the short end of the LED, where the current will be flowing out, is connected to row 11. So if I take one more wire and connect that to row 11, I'm almost ready to see the light come on. All I need to do is complete the circuit by connecting this wire to ground, to 0 volts. So let's give that a try. And sure enough, the light comes on. So that's pretty exciting. We've now figured out how to turn the lights on. When I have a complete circuit from 0 volt.
Cool. This won't work for me right now because it is not plugged in. But let's get this plugged in here. That's plugged into ground. I'm going to need to move this around, or move where my computers and stuff are. Ground, here's one here, GND, perfect. Bling, and I'm going to plug it in over here, and the light should light up when I plug it in. Yeah, cool. So look at that, LED is lit, if you can see that. Great. It's just got constant power going through it, so it's just constantly lit. Let's finish this up, and then we'll talk a little bit more how we're going to do this going forward.
Rather from 5 volts to 0 volts, passing through the resistor, and is get the Hero involved in an intelligent way. We'd like the Hero to take over the job of connecting and disconnecting the voltage to our circuit. And so that's our next step right now. So we will, for the moment, disconnect our circuit.
Oh, Willie.
And shift our attention for the moment to the Hero and how we can control the Hero. Now, what we have, I will direct your attention next to our code window. What you see here is that the code that is illustrated in this window has a particular sort of structure to it, sort of syntax to it. What we'll find is that the code that's
I need to pause for just a moment. Can I pause instead of stopping? I don't know. There was just something beeping. I don't know what it was. Let's keep going.
Understood by the Hero consists of statements, and generally speaking, a statement ends with a semicolon. That's how you can recognize it. And you can group sequences of statements
beeping on his end.
inside these curly brackets. And so you'll notice I have one routine here called setup.
Yep,
So,
we know this part.
okay, so let's go to defining a variable called light.
Cool.
This is just a number, an integer, and I've chosen to give light the value of 12. INT here means that it's an integer, a counting number. And its name is light, and its value is 12. Now, I want you to notice that when the semicolon is typed here, that's the end of the statement.
Mm-hmm.
And that's as far as the computer, the hero, will interpret
we get it.
But there's something after the semicolon that's fairly
It's a
important.
comment. Yeah, we
That
know.
is, anytime you see 2 slashes followed by some text.
Okay, so there, it's great. Let's do this. I don't need you anymore. Let's just, should I start a new one? That means I'm going to have to freaking, cool. Let's close this. Don't save it. Can I make a new one? A new file? A new, nope, that's Chrome. It's not even open anymore. Why is it giving me that dark thing there? It says blink. That is not open even a little bit. Arduino IDE. Cool, there's that. Hey, look at this. We don't need you anymore. Sorry. Great. Cool, here's our thing. I'm going to make an integer that is called light. Put it up here. Int light equals 12. It doesn't need the semicolon, I guess. Let's find out what happens next.
That's a comment.
Yeah, it's a comment.
Oh,
Great.
Let's try comment. I've set up the hero to get
Yep,
this started by
yep. Get to the good stuff. Oh, great.
pin mode takes as its first input right here
Okay.
a variable, in this case light. So we know that we're telling pin mode, I want to do something with pin number 12, another name for light. And then it has a function right here. And the function that I want to apply to pin number 12 is to make it an output. And what
Cool.
that means to the hero is that with pin 12, you're going to be asked to change its stats, to do things to it.
Okay.
Make its voltage be high or make its voltage be low. So this is what pin mode does, is it assigns a function to pin number light, or pin number 12. Following the pin mode and its semicolon is another statement, digital write. Digital write now does something to that pin, in this case pin 12. And what it says is set its voltage to low.
Cool.
Low is just another way of saying 0 volts. So when we see high, we're going to see 5 volts. And when we see low, we're going to have 0 volts.
Mhm.
Now actually, since we'd like to turn the LED on, let's change from low to high.
Why did you have low
That
there?
way, when this is executed, pin 12 will now be at 5 volts, and that would be very useful to us.
Cool.
So let's go ahead and see if it works. Let's come back over to our circuit. And instead of taking our wire here and connecting row number 6 to 5 volts, which would turn the light on, let's
Mhm.
connect it instead to pin number 12. So pin
Okay.
number 12 is right here. And not surprisingly, nothing's happening. The light's not on. And the reason why the light is not on is right now, since we have not run any code.
Okay, so connecting my guy here. This is such a mess. So right now it's connected to the 5-volt out hot thing. I want to hit pin 12, I guess. That's what we were saying. Yeah. Cool. Great. Good time.
Code. Pin 12 has no assigned function to it.
Mhm.
So let's go ahead and upload our code to the hero and see what happens. So upload our code, and the light comes on. So we've now succeeded in turning on the light, but without actually touching the circuit.
I've not succeeded in that. Oh, you know why? Because it is not plugged in. Note to self. Let's see if we can have this plugged in as well. Okay, cool. Let's run our code. Here is my light. Let's see if we can see it light up. Missing FQBN. No board selected. Oh, do I have to select a board again? And this one? Great. Select another board import. I do want to upload a sketch. The board is the. Do I have to? I don't have to do this every time, do I? It was the Uno or it's the Hero, right? But it wants a Hero, or wants a Uno. Sorry. Arduino Uno port boom. Great. Now let's see if this works. Verified. Great. Upload. Hey, it lights up. But you can't really see on camera that well. There we go. Just like he said. There's got to be a better way to do this part, but we'll figure it out.
We've allowed the hero to do that for us. We can change the status if we want. We can change the code from saying voltage high to voltage low, or 0 volts. We should now have no current flowing. And so if I upload the code now, the LED goes off.
I believe you.
That's super progress. We've now succeeded not only in turning on the LED, but
Mhm.
controlling the LED being on or off by giving commands through the hero. Now, that's interesting, but we haven't even touched the loop function yet.
We haven't.
And that is going to be very interesting for us because the loop function allows us to do things repeatedly. So let's see if we can't do something a little more interesting by putting some statements into the loop function to
Okay.
be executed repeatedly.
Great.
All right. So I'm going to use digital write again. But I'm also going to use a new function, and we'll see what that function is in just a moment here when we take the code and we paste it in. You'll notice, by the way, while I'm doing this, that we did have an appropriate comment in setup. We said that we are initializing the digital pin, in this case pin 12, to set its value to high. Now, what we're going to do in loop is we're going to change the status, and we're going to do this repeatedly as long as the hero is turned on. So the first statement in loop does something that might seem a little pointless, and that is it says, change the value of light to 0 volts, so low. Well, it's already off, so it might seem like a sort of a pointless thing to do. But stay with me, because what we're going to do in our next statement is execute something called delay. Delay simply waits for a specified period of time. In this case, it waits for 1,000 milliseconds.
Yeah, we did this already.
Off for a second, on for half a second.
Yep, great. So I just wrote that part here in my code. Digital write light low 1,000. Let's see if this works. It should. Okay, there we go. Hey, look at that. We did it.
On, off, on, light. So, for example, we might say, well, you know what I really like is I'd like the light to be off for 2 seconds.
Sure.
And then I might say, okay,
Yeah, we know that.
control our analog circuit. We experiment a little bit on your own. You might be able to write yourself some code that will flash out a message in Morse code, or do something else that might be interesting in terms of turning the lights on and off in some specified way. But for now, we've been able to demonstrate and work out the basics of both an analog circuit and its digital control, and that's just exactly what we wanted to do in this session.
Great.
So for now, you can go ahead and practice with this, and we'll sign off for now, and next time, we'll see if we can do something even more interesting using our breadboard and our hero control. So for now, remember, invent safe, and we'll see you next time.
Great. Cool. So that's that. This is pretty basic code, like super basic. Unless you're not a coder, then welcome to coding. I've got my thingy blinky. It's great. I can do that. I've got my stuff set up. So here's what's going to happen going forward. I'm done for now. I'm going to fuss with OBS, and see if I can get a better setup here so you can see this moneymaker here and all the stuff over on the left side and the code and all that, now that I know what we are doing at all even. So I'll set that up, and yeah, it'll be a good time. I don't know how often I'm going to do this. Probably not every day, spoiler alert. But yeah, if you were hanging out with me, I lost my chat when I restarted, so thank you for hanging out. Thank you for joining me on this weird little journey. 2 days down, 28 days to go. Great. If I had a goodbye screen, I would put it here, but instead I'm just going to wave goodbye while I hit my bye button. Goodbye.